Okay, thank you to my friend. Firstly, I want to introduce myself, and my name is Muhammad Shafiq bin Hazim, and my matric number is 01DKA20F2010. Okay, we continue calculation about the beam. Okay, the first thing we need to check the section, and from this question, the section is 203 times 133 times 25. Okay, the first thing we need to find the load analysis from vector load and weight of column, and next we need to find total load and total action, and the last total load we need to plus total load and total action. The second step, we need to find the classification of section. Before that, we need to know the material properties from the Eurocode. We need to check the steel grade, and this question steel grade is for 430 275, and thickness is lower than 40 mm, so Fy is 275 and Fu is 430. And classification, we need to find the flank and web subject. Use the formula of flank and web, and the value of flank is 1.8 and flank is in class 1, and web subject is and the value of web subject is 30.36 and web is in class 1. Okay, the next step, we find a column slenderness, and this step we should focus for find LCR YY and LCR ZZ, and from this question we can got a value of LCR YY, and the value of LCR YY is 0.65, and for LCR ZZ we got the value of LCR ZZ is 1.79. Okay, next we need to find compression resistance and buckling resistance. Okay, compression we need to find NCRD using the formula, and after we use the formula and we got the value of NCRD is 880 kN, and next we compare with NED. So NED 222.91 kN less than NCRD 1818 kN. And next we need to find buckling resistance checking or NBRD. Same with NCRD, we find NBRD use the formula, and NED value is same, and we get after we get the NBRD. Okay, the first we find value of X using the formula H over B, so we get the value of X is 1.53, and for YY axis we find the value of YY axis and we get 0.76, and next we multiply with value X, we get the value of XY is 0.87 less than 1.0. So and BYRD we use the formula and get the value 765.6 kN, and lastly we compare with NED. So NED 222.91 less than, and BYRD 765.6 kN. So the answer is okay. Okay, lastly we find value for ZZ axis. Like with YY axis, use the formula and we multiply with X, so we get a value 0.27 less than 1.0. And last, we need to find value of NBZRD, and we got the value. After that, we compare with NED, so the last value, the last answer is 222.91 kN less than NBZRD 237.6 kN. So the answer is okay, and that's all from me. Thank you.
Assalamualaikum. I will intro myself first. My name is Muhammad Hazim and my matrix number is 10DKA20F2025. For this slide, I will present about beam B over 122. For the GK is 0.70 kN per meter cube, and for the QK is 0.60 kN per meter cube, and for the Ly over Ls is equal to 1.0. That's mean two-way spinning. You can see the diagram over here that we doing. Okay, for the loading analysis, for the step 1 is the design action equal to 1.85 kilonewton. For the total action, B over 1 to 2 is 21.31 kilonewton, and for the Mmat, the formula is WL over X equal to 17.05 kilonewton, and for the Vmat, for the formula is W over 2 equal to 10.66 kilonewton. Okay, for the next step is determination of trial section. We assume for this beam is S275, and for the section is 203 times 133 times 25 universal beams. Okay, for the plastic modulus is 258 centimeter per cube. Okay, for the next step is classification of cross section. Okay, we must find the flange subject to compression. For the formula is S over T less than 9 epsilon. Okay, for this flange is in class 1 CT over CF equal to 7.20 is less than 9 epsilon equal to at 8.28. Okay, for the web subject to bending is CT over T less than 72 epsilon. Okay, for the web is in class 1 CW over TW equal to 30.2 is less than 72 epsilon equal to 6.24. For this slide we have step 4, step 5 and step 6. Okay, for the step 4 is shear resistance is to certify VED less than VCRD. Okay, for the VED is Vmax is equal to 10.66 kilonewton. Okay, for the EV is equal to 30085.1 millimeter square, and for the NHW TW is equal to 1069.32 millimeter square. That's mean AV more than NHW TW. Okay, for the VCRD equal to VPLRD is 14329.93 Newton or 1432.9.95 kilonewton. Okay, that's mean VED 10.66 kilonewton less than VCRD equal to 1432.9.95 kilonewton. That's mean it's okay. Okay, for the step 5 is shear buckling for web is to certify HW over TW less than 72 epsilon over N. Okay, for the HW TW is equal to 32.19. Okay, for the 72 epsilon over N is equal to 66.24. That's mean HW over TW less than 72 epsilon over N. Okay, that's mean it's okay. Checking is not required. Okay, for the step 6 is bending moment resistance. Bending moment resistance is to certify the MED less than MCRD. Okay, for the MED is Mx equal to 17.05 kilonewton, and for the MCRD is equal to 70950 kilonewton meter. Okay, for the MED, that mean is MED 17.05 kilonewton meter is less than MCRD equal to 70950 kilonewton meter. Okay, that means it's okay. For this slide we have a step 7 and step 8. Okay, for the step 7 is combined bending and shear resistance. You can see the picture for the reference. For the Vmax and for the Mmax is 17.05 kilonewton, and for the Vmax is 10.66 kilonewton. Okay, for the VED at Mmax is equal to 0 kilonewton. Okay, we do some calculation. For this combined bending is 0.5 VCRD equal to 0.5 times 1432.9.95 is equal to 7164.975 kilonewton. Okay, That means VAD at Mx equal to 0 is less than 0.5, VCRD equal to 7164.975 kilonewton. It means VED is small and it does not affect the moment resistance. Okay, for the last step is vertical deflection. Is delta max less than delta allowable. Okay, for the delta max is equal to 0.0024 millimeter, and for the S allowable is equal to 24 millimeter. That means delta max is equal to 0.0024 millimeter is less than delta allowable equal to 24 millimeter. It means okay. Okay, that's all for this presentation. I will pass to the next presenter.
Hello everyone, before I begin, allow me to introduce myself. My name is Athirah binti Jafridin. My metric number is 01DKA20F2011. Now I am going to explain about roof trusses at member 9 to 10. As you guys can see, now that we have load, we are going to find internal force by using sin constant. Next, we are going to determine X, which is NED. Here, as you guys can see, NED is 5.15 kN. Trial section that we choose is 100 times by 75 times by 10. As for Fy is 275 nmm square and Fu is 430 nmm square. You can find Fu and Fy based on table 3.1, which is on Eurocode. And for D is 20 mm and for DO is 22 mm. First of all, we are going to determine NCRD, which is the formula is AFY per gamma MO. Always remember to change N to Kn, which is divided by 1000. After done with the calculation, we will get NCRD equals to 456.50. Therefore, NED equals to 5.15 less than or equal to 456.50 kN. So it is okay. Moving on to the next slide, we are going to determine NED less than or equals to NBRD, and the formula is X AFY per gamma M1. We need to find NCR first because we are going to need NCR value to find rho. Pi is also one of the important value here. After done with the calculation, NCRD equals to 10.43 kN. This is after converting it from N to Kn. Therefore, NED equals to 7.75 less than NCRD, which is equals to 100.43 kN, so it is okay. And last but not least, we are going to design the tension member. Shall satisfy NED less than or equal to NTRD. The formula for NPL is AFY per gamma MO, and the value for NPLRD is 456.5 kN. Now we are going to find value of A net. Formula for A net is A minus A bolt, and the value for A net is 1440 mm. Therefore, NURD equals to 0.9 times A net times FU divided by gamma M2, and the final answer is 445.824 kN. And that is how we calculate roof trusses at member 9 till 10. And finally, this is the design output drawing of these trusses. That's all from me. Now Athirah will continue this presentation. Thank you.
Hello and hi everyone, my name is Athirah binti Razali and my registration number is 01DKA20F2002, and now I'm going to continue the presentation by sharing to you the design resistance of bolted connections in figure 3. Okay, so this is the detail for the bolt connections, where for the diameter of the bolt is 20 mm, the grade of the bolt is 8.8, and the grade of splice plate is S275. Based on the details above, we can find out the E1, E2, P1 and P2, where E1 is parallel to P, which is 50 mm, E2 perpendicular to P, which is 50 mm, P1 parallel to P is 75 mm. Okay, so the first step, we need to find the shear resistance, where we use the FVRD formula, where the final answer is 94,080 Newton or 94.08 kilonewton, where we use A 245 mm, FUB 800, lambda M2 is 1.25 and AV is 0.6 for bolt class 8.8. Okay, so next we need to find the bearing resistance by using the FBRD formula, which is K1 multiplied to AB multiplied to FU multiplied to D and multiplied to T divided to lambda M2. So the FU is 430 N millimeter, T is 20 millimeter, T is 10 millimeter, lambda M2 is 1.25, K1 is 25 and AB is 0.76. Okay, so by using the formula, we get that the final answer for FBRD is 30,732 Newton or 130.72 kilonewton. Okay, so next we need to find the tension resistance where we use the FTRD formula where it is 0.9 multiplied to 800 multiplied to 245 divided to 1.25 and we get the final answer is 1,411 and 20 Newton or 141.12 kilonewton. And for the last step, we need to find the tensile resistance for cover plate where we use the NURD formula which is 0.9 multiplied to FU multiplied to NET divided into 1.25 and we need to find the NET first where we get 3,680 millimeter squares and from there we could find the NURD by using the NET and we could see that the final answer for NURD is 11,393 and 28 Newton or 11,039.33 kilonewton. Okay, as you can see on the screen, this is the drawing that I drew for the bolt connections by using the SketchUp apps based on the figure 3.